If you are officially starting or when we are starting, now everything is ready. Yeah, you please start. Okay. Good evening, all. It is my special privilege to address online a program conceived by Sri Manish Purohit, who is a long friend and who is doing an extraordinary job to reach out the space education, not only space, science and technology education to the rural parts of Rajasthan, not necessarily Rajasthan alone. Whoever is interested and associated with Nimbus education system, they are getting benefited by the efforts made by Manish. Also, I would like to acknowledge at this time, uh, he is doing an extraordinary work representing space subject in the national television and other media. I would like to congratulate and laud him. It's a good job you have been doing. Please keep doing it. As a part of National Space Day, which is the second year, you may go to the PPT, Manish, which is being celebrated across the India. I was also fortunate enough that I have been given an opportunity to work in organizing committee both at Mysore, Lucknow, Patna and other areas. Generally, the trend or pattern is that all over India, various ISRO centers will take the lead in formulating the committee and making such a way that a beautiful, nicely organized National Space Day before 23rd. Finally, it will culminate tomorrow. It's going to be a huge a celebration tomorrow in Delhi at Bharat Mandapam. That is the little bit background about a year-long celebration. Anyhow, you know why 23rd August is declared as a National Space Day. It is because that India, ISRO or Chandrayaan 3, the lander Vikram or a Pragyan rover, which has landed a soft landed near the South Pole. To commemorate that day, Prime Minister Modi has declared 23rd August of every year. It will be a National Space Day celebrated across India. That's what the last 2 years we have been doing, and it's a great moment. So the previous slide, yeah. Every year the different theme is there. For this year it is Aryabhata to Gaganyaan, the ancient wisdom. That is the kind of theme has been given for this year. When it comes to the India's what you called long and proud history in the field of astronomy and space science, we have a tremendous history. Those who have not studied in college or school, I request people to go through the ancient astronomy books available in Amazon, elsewhere, even in regional Hindi and other languages. If you look at our ancient thinkers, there are so many are there. Aryabhata, Varaha Mihira, so many people have contributed theoretically those days, whatever the best possible. So India has a long history of achievements of Aryabhata to till recent days like Chandrayaan, Mangalyaan, and very what you call new event which has happened very recently is Shukla's travel to International Space Station. So you've got a tremendous history behind you, scientific and technological achievement, knowledge, and a lot of innovations are there. I would like to request students to read about such kind of things. India is very rich in terms of astronomy and space research. Of course, when we say this word, we are very cautious. Other countries are even advancing much ahead of us. But however, we were no way less than any other advanced country. So considering those things, we should focus more towards in future for the advanced science and technology in both space and other areas. So just to say, we have about more than 1,500 years of science innovation history. Next slide. So this is to just acknowledge that I attended one of the talk by Siraj, who was an IAA director. He was mentioning about the contributions of various Indian astronomy and the area where they belong to India. As I told you, Aryabhata one, who is from Bihar or today's Patna, that region. Varaha Mihira. Those who have not heard these names, please make a note of these names. Try to Google, try to get the books written by them. It is available both Sanskrit, English, Hindi. Try to read about them. Bhaskaracharya. So many other Nilakanta Somayaji from Kerala, Leelavati, there are like that. So many our ancient people have contributed for the development and growth of astronomy. Never mind that is continued even till date of what ISRO's achievements, what we are seeing. Next slide, please. So it's a just a glimpse to tell that you should not be feeling sad that we don't have a good history of that is not the case with respect to India. Just to give, because today's topic is Aryabhata. What Aryabhata's contribution? See, if you ask me now, today's term, today's what you call scientific era, any discovery, invention, observation, study, we represent that in terms of a paper, research paper, we say, which will have a title, co-authors, authors, then objective or abstract, then introduction, like that. That is the way that science is being represented after either theoretical or practical observation. Whereas if you ask me, in the olden days of India, they used to write in terms of two-line slokas in Sanskrit. So here, this first sloka, I have written it in Kannada, don't mistake me, it is in Sanskrit actually. The meaning is I have given in English. Most of you are aware what is ecliptic. It is an imaginary line or a path on which sun and the moon moves from eastern direction to western direction. If you look at it, this is the kind of wisdom knowledge we acquired. Where did we get this knowledge? It is because of Aryabhata's invention or a discovery. He has written Meshade Kanyantam Samamudan Ashamandalardam Aya Apayatam Taulyade Meenantam Sheshardam Dakshinana. It says half of the ecliptic from beginning of Aries to Virgo is tilted towards northern side. The other remaining half is tilted towards southern. Those who are habituated to using stellarium, please take that stellarium and put this ecliptic plane and check it. You will see the Aries to Virgo, which will be towards northern, all those constellations. Similarly, he has also mentioned about planets and the moon, how it is rising, how it is setting. Next slide, please. I will not be reading each and every one. I am just giving a flavor that those days the research or finding and observations are written in two lines. In Sanskrit, people may mistake that these are all shlokas to be recited in temple or during religious times. It's not so. Scientific knowledge which is hidden those days in these by Aryabhata. The moon moves from south of the Apamandala ecliptic plane to the north in downward motion, as do planets, Mars, Jupiter and Saturn and other planets like Mercury and Venus. This is one thing. The other one is during the Amavasya, we will not see the moon in the sky. When you will start seeing first, when moon appears around 120 degrees from the sun. If it is 180 degree, in the sense it is aligned in line with the or 0 degree or 180 degree we say. Similarly, Venus after 9 degrees it is visible. These are the kind of calculations which are written in terms of shlokas. People have to put some kind of a knowledge and understanding of those things. But nowadays, same observation are available in terms of research papers. Next slide. So what I am trying to tell you is our ancient people had an observation, beautiful observations, beautiful calculations, and they have presented in the form of shlokas, which are nowadays you don't have to put more effort in Sanskrit also. All are translated to English and local vernacular languages. People can understand. Very interesting. One more ancient contribution is the Madras Observatory, which you are right now seeing. It was established in 1792. So people have what you call planned, next slide, planned from this particular observatory to observe the eclipse in 1868, total solar eclipse, which was an important event which happened or observed from Andhra. I think it is somewhere near Guntur. People have observed, world scientists have come there and they have observed. That was an interesting day or interesting event where the helium was observed or detected, or what we can say invented. We can say credit goes to many of those days, what we call now middle level, not ancient scientists. It is during British era. So middle level Indians who have made, of course, entire credit goes to the scientists who you are now right now seeing. But however, it was Madras Observatory which took lead in terms of managing how to observe the solar eclipse in 1868, which resulted in a great discovery of helium. Next, please. Next slide. I have a small request. My slides, I will not be speaking whatever I have shown here. Little bit I will be drawing your attention. So if you look at it, after the Madras Observatory, during early independent days, we got many observatories. Till now, what are all the ground-based observatories are there? This is the list. Next slide, each one I will be showing there. Next slide, please. So you got now in India huge number of observatories. What do you mean by an observatory? It could be a small telescope, it could be an antenna, it could be a reflecting mirror. This is what you are seeing. These are the different parts of a telescope to observe astronomical event or the sky. Next slide, please. What are all available in India? You have Girwali Observatory. You can see there in the map in India. I have shown where it is located. This is how it looks. Right now, people are doing a lot of observation. From here, maybe quickly you can go because every observatory I am showing here. Girwali Observatory. Next observatory, please. The Himalayan Chandra telescope. Lot of activities are happening at nearby Leh Ladakh in the Himalayan region. This Chandra observatory or optical telescope is being operated from Bangalore near Hoskote. A lot of PhDs are being done by many researchers. Next slide. Here I am covering a lot of this high energy gamma ray telescope again, which is there in the Himalayan region, which is yet to, I think it will be available maybe for the students to observe. Next, please. This one is Venuvapu Observatory, good old observatory. People are using it, which is there in Tamil Nadu. Next slide. Mount Abu, which is there in Udaipur, where right now it is available for students. A lot of PhD students are there. It's a beautiful facility and good location too. Maybe you have to understand when you have a telescope that sky should be very clear. It's one of the best places, both Himalaya and these places. Next slide, please. Aries, which is there in Nainital, Uttarakhand. It's also a very premier institute for research for astronomy and astrophysics. Students can apply their summer courses or even they can join for their PhD and other fellowships. Next slide, please. Udaipur Solar Observatory, I think many of you are maybe nearby or it belongs to your state, which is inside a man-made lake where it is being used for observing the sun. Next slide, please. Ooty telescope, which is well in southern India, in Ooty, which is observing in radio frequency. Here also a lot of scientific observations have happened. A historical place for radio astronomy. Next slide, please. Yeah, this is a place where I belong to. This is from my village, Gauri Bignur Radio Telescope, one of the fantastic facility. I may not be telling who is doing all those things. Maybe for students is an assignment. Whatever so far telescopes I have shown you, you can Google it. You will come to know. From here, a lot of sun observations have been done. Quite a good amount of research has been done. I think this belongs to IAA. Most of the telescopes which are shown, either it belongs to IAA or PRL or what you call the Aries. So that is the kind of institutes. You can have a look at those things in Google later. Next one, please. I'm just trying to give you the glimpses of ground-based telescopes available. Next slide, please. This is another interesting, very large array of antennas. We call it as a giant meter wave radio telescope, GMRT Pune. You can see this, the person who has installed this particular facility. Next slide, please. Which is there near Pune. Another one is important observatory is Kodaikanal Solar Observatory. Large amount of data they have collected and it is made available. So all these slides, which I really got education from one of my friend who is there working in planetarium, I would like to give due courtesy to him. Just to give you glimpses, next slide please, glimpses of what are all observatories available. With all these things, how in India the space has evolved. Let us have a look at it. At this point of time, we should really remember Dr. Vikram Sarabhai, who is considered as a father of India's space program, who started very modestly in 1962. At those days, ISRO was called as INCOSPAR, and under that particular umbrella or institute in Tumba, which is there near Thiruvananthapuram. Tumba is the name of a seashore village or a fishing village From there, in 1963, for the first time, sounding rocket. When you say sounding rocket, sounding means to measure, to record, or to observe, something like that. Sounding rockets were launched. August 15, 1969, ISRO was established. Then we had a vision, space technology for national development. That's how we moved on. Then in 1975, for the first time, the it's April 19th, if you exactly remember the date, Aryabhata was launched from I think from the Russian vehicle. Now go to the next slide. The satellite was made in Bangalore, Kenya, and it was launched from Russia. So if you ask me what was the good old days, in those days, what was the vision is, we must be second to none in the application of advanced technology to real problems of man and society. Of course, we have moved on. The vision given by our Vikram Sarabhai, with due respect to him, we also moved on. I will be explaining in future. We have reached to the moon, we have reached to the Mars, we have landed on the moon as well. We are planning to have a bigger missions. So this was a very humble beginning by Sarabhai in Tumba, which I earlier mentioned, where sounding rockets were launched. The church which you are seeing is a Mary Magdalene church. The Vikram Sarabhai goes to the church and asks the father of the church, or a priest of a church, to hand over the entire building for making rockets. Can you imagine, rockets in India are made in church? Can you believe it? It's just a kind of the India is like that only. So it started from a church. Today it's a very beautiful museum. Any of you visiting Trivandrum, you can apply and go to the museum and you can see it. Next slide, please. So this is how it looks. It was a small fishing village where, for the first time, see why this particular place was chosen is it was very close to equator, very close to equator. However, a geomagnetic equator was very nearby, near the Tumba. So that's how United Nations has granted this as a international facility for observing the atmospheric, or making some measurements. First Nike Apache rocket was launched, and it was given by USA, and payload was given by France, and it was launched in this very beautiful place called I think it's a Valley Beach they call it as, or you can call it as a Tumba. Please try to remember Tumba Equatorial Rocket Launching Station. We call it as a TERS. Next slide, please. That's how it started. Then the ISRO has picked up with lot of indigenous developments, and the rocket as well as satellite. Same time, Vikram Sarabhai has chosen many of stalwarts of those days. One of them is Professor U.R. Rao, who was an expert in United States working on certain satellites of NASA. He has been asked to come back to India and make satellite for India for the first time. That is called Aryabhata, which was launched in 19th April 1975. It was very well made in Peenya sheds of industrial area near Bangalore, with very minimal technical support, or very minimal electronic support in those days. It was the first X-ray astronomy satellite which made India to enter into the space. Like Sputnik is the first satellite which has revolutionized the space. Same way in India, Aryabhata, in the name of our great mathematician who gave zero to many discoveries are there in his name. Of course, it worked for short period. Later, next slide. Later, ISRO developed into a huge space ecosystem in India. The sequence of development is like this. 1963, Rohini was launched. Then Rohini series were launched in up to 1967. Indigenous satellite launching vehicles, we call it as SLV, PSLV, GSLV. Later, we also entered into Earth observation. And when we say Earth observation, taking photo of Earth, resource management. Then communication satellites like INSAT, GeoSat, weather observation and forecasting and disaster alerts. Such kind of applications are possible right now. Every 1 hour we are able to give weather forecast. Same way for astronomy and astrophysics also, a lot of satellites till Aditya, Exposat, Astrosat, and deep space missions such as Chandrayaan, Mars orbiter. Chandrayaan series is Chandrayaan 1, 2, 3, Mars orbiter mission, Aditya L1. Later the development went into a bigger scale, like to commercialize the space. So New Space India Limited, which is a commercial arm of ISRO, has started. recently in 2023, India has also announced its India space policy, wherein you have established a private, what you call enabler called Indian National Space Authorization and that is InSpace, which was established. Right now, it is headed by Pawan Goenka InSpace, which is will help all private players also to see it's a government business. Space is a government business all these years. Now, after the establishment of InSpace and other, now any private sector can start the business in terms of in the space industry. Next slide, please. So that's how the overall evolution of ISRO in a very nutshell or in a short brief. If you want to talk more about history, you need hours together. I will restrict myself whatever available time. So this is the overall distribution of government sector. I have not put private sector here. All ISRO facilities, fairly good, but still we need more. Even the northern part should be covering more institutes. However, we have a lot of regional remote sensing centers in the every state, and state remote sensing centers are there. If you ask me, important centers are Vikram Sarabhai Space Center, which is lead center in design development of rockets. UR Rao Satellite Center in Bangalore, which is a lead center for design development of satellites. Space Application Center, which is an important center which makes a lot of application related payloads, cameras. Same way in which I work is called ISTRAC. We control 25 to 27 satellites, including Chandrayaan as well as other Astrosat, Aditya, all those things. Whereas in master control facility in Hassan, which also responsible for all geostationary or communication satellites. You name a city we have now. Of course, if you include private industries here, every state has a space enterprise or a government or a private enterprise. So India is becoming, if you recall 50 years back, space means nobody knows. Today, space is in every person's life. Everybody, a small village fellow also will talk about rockets, PSLV, GSLV, like that. So space is integral part of all of us. Please, next slide. So just one point before I go to this slide is, see, there are so many countries which started along with India. For example, Sri Lanka, Pakistan, Brazil. Many countries started in the same time scale when Vikram Sarabhai started Space Industry. Because of the Sputnik launch, entire world wanted to have their own space agencies. India is one among the 5 countries to have such a self-sustained, self-reliant, consistent space program. No other country has it after USA, Russia, and Japan, China. Then we belong to that category. That is the kind of status space industry is giving to the India. So for India, you have now a very reliable PSLV, Mammoth, or a big GSLV, then GSLV Mark III, very small satellite launching vehicle called SSLV, LVM3, which was used for launching big satellites. So this is the strength. So generally, I used to tell, if you go to any other countries, what is your manufacturing capability? I manufacture cycle, I manufacture bike, I manufacture car, like this. Name a particular moving vehicle, India manufactures it. That is the greatness. So if you add this launch vehicle into that category, India has all classes except 50-seater aeroplane manufacturing is not there. There are certain exceptions are there. Otherwise, from cycle to rocket, India is self-reliant. We are having all industries here which can manufacture. Even I think 4-seater, 5-seater Surya Kiran is there. Small Tejas is there. We are manufacturing such kind of a flying machines as well. However, in terms of rocket industry, India is self-reliant. That's the point which I wanted to make in this particular slide. Next slide, please. This is another interesting experiment which made India proud, or the technologically strong, is a reusable launch vehicle, which landed in Chitradurga, which is around 180 kilometers from Bangalore. In future, we would like to see a vertical liftoff, puts the satellite into orbit and comes back and lands, which was similar to, I think, shuttle or a Discovery or Challenger or such kind. There are 7 category Endeavour. In that direction, it's a good, interesting experiment which gave ISRO and many aerospace engineers to understand how to design such kind of vehicles. This is an interesting area which is under development, hopefully to see in future as an operational launch vehicle system. Next slide. This is a year or a year and a half back. This was launched as a part of Gaganyaan. This is a unique experiment. We call it as a test vehicle. D1, D2 is in progress. And what it is the first time what you call it will go to the certain height around 15-20 kilometers of that order, and releases the what you call as a crew module. It will splash down into the ocean. From there, you have to pick up or recover or collect it. That's the team which was involved in recovery of course, in this one, humans were not there. It's a rehearsal towards the human mission, which is the Gaganyaan, so which was successfully done. Interesting thing is, in this particular test vehicle, first stage was a liquid engine. I didn't mention more about the stages and fuel. Just to please note it, for the first time we have what we call flagged off first stage, which is a liquid engine. So it's an interesting experiment which gave a lot of learning how to what you call recover the crew module, which you have seen in case of a Shubhanshu Shukla, how Dragon capsule was more or less same, but some different technologies of indigenous, our own methods are used in this particular one. Next slide, please. This is the overall development in future. Maybe by 2030, we should have our own vertical takeoff, vertical landing, Hawa, a vehicle which runs with breathing air. This is a long, big program. I think tomorrow is kind of a even bigger than 2047 vision will be outlaid by the Prime Minister of India, Chairman ISRO. So it's an interesting thing. This is a old slide. However, India is having very ambitious plan. People like us, we can work another 15-20 years, we may leave ISRO. Students who are now either in engineering or 10th, 12th class, you become engineers, you have to lead the country towards this vision. That's how the current leadership in ISRO is setting a long vision up to 2047. Next slide, please. This slide may be very big one, but don't worry about it. We have got more than like Earth observation satellites, communication satellites, interplanetary satellite. Then we have a moon satellites. We are also aiming towards the Venus, towards the what you call landing on the moon. That's how. See, if you look at the last 50 years, the evolution of satellites in India is tremendous, and it is excellent progress has been made, but still we need to do more. So a lot of applications are there with the satellites, from a common man to a rich man. That's how satellite plays an important role. Nowadays, all these satellites need not to be made by ISRO. Many startups have come up. They are taking the knowledge or technology from ISRO. Already 2-3 companies are operational. I will be telling when that slide comes. That's how. Here I have not added a government only government satellites are added. A lot of private satellites are also now operational, built by India. Next slide, please. Just for giving an idea, because what do you mean by a satellite? Any object which is orbiting around Earth. In fact, Moon is a satellite. We call it as a natural satellite. Similarly, depending upon the type of orbit, depending upon the inclination of the orbit, different categories of orbits are available. Polar means 90 degree, pole to pole. Equatorial means 0 degree. Low Earth means less than 1000 kilometer. Medium Earth means more than 1000 kilometer. Geostationary mean which is fixed at a distance above a particular Earth place, or at a distance of 36,600 kilometers. There are certain ecliptic planes or elliptic planes are there, which will be used for going to moon and other things. Hyperbolic, which are what you call flyby type of a thing. This is a simple idea knowledge. You can study in detail in your academic thing, how orbit is conceived, what type of orbit is beneficial for what type of applications. That's how you will learn more about orbits, satellites, and applications. Thank you. Next slide, please, for this. This is an interesting thing. When you go to a moon, how do we go? We know the orbits. With that, those type of orbits are not sufficient here. You will have a slingshot methodology because of our rocket, which puts into a perigee and apogee type of orbit, 500 by 3000 or 15,000, depending on different launch vehicle capabilities. So slowly it has to undergo up to 1 lakh kilometer. Beyond 1 lakh kilometer, the Earth's influence will reduce. Then if you fire engine, it will move towards the moon. That's how the trajectory, one example of trajectory, how to reach the moon. So far, the best or the optimum or less effect or cost effective is, less cost. The trajectory is India's methodology to reach the moon. Whereas US people will launch in a single shot, 5 days they will reach the moon. We will have a slow methodology and reach the moon within a month or 2 months. That's how the strategy is there. Next slide, please. Another interesting strategy is, which was recently demonstrated a 1.5 year, 2 years back, maybe by January it will be 2 years back, where reaching to Aditya. See, those orbits are not beneficial here. Earth, around Earth, elliptical, polar, geostationary, or whatever, slingshot, all those things are good. But when you go to, this is not, we are not entering into the orbit around the sun, but we are going certain 1.5 what you call million kilometer away from the Earth, where you get an opportunity to stand still. We call it as a Lagrangian point. The diagram says there are 5 Lagrangian points. Those who are interested in mathematics, they can study how to solve the Lagrangian equation between Earth and the Sun system. You will get the 5 points where gravitation will be more or less equal or nullified or a balance, whatever you want to say. Where if you place a satellite, you will get a continuous observation capability, also continuous transmission capability towards Earth. This is the kind of, for the first time, Indians have demonstrated this capability, which NASA and maybe ESA, these two countries have acquired this particular. See, technology means not necessarily making rocket satellites. Also, the mathematics behind this mission operations, we say that mathematical knowledge is very, very essential. So they have done. They have proved it. Now satellite is there in the Lagrangian point. Lot of, here I'm only drawing your attention towards the type of orbit which the Aditya mission has been placed at Lagrangian point. That's the point I'm trying to say here. We can talk more about Aditya L1 alone itself in a long term. My attention is to only nature of orbit and the mathematical capability of Indians. I told you Aryabhata was a great mathematician. Now today in my office, one engineer who has made this from Himachal or Uttarakhand, I think I used to call him as Negi Saab. So he has, his team, many people have done it, not one person to name. So that is the kind of mathematicians right now India is having. So we never depended on any outsiders for this particular. Our own mathematicians have demonstrated. Next slide, please. We can talk a lot on this one. This is another capability demonstration where you have started from a kilometer, what you call pixel. 1 pixel equals so many kilometers, to right now India is having the finest camera being operated in space, that is around moon, Chandrayaan-2. We call it as orbiting high resolution camera, which gives around 27 to 35 centimeters. That's the order of. And also, of course, we have a 1 meter or less than a meter in Earth orbit also, which gives you high resolution pictures. You please visit to Bhuvan, where you can see certain selected cities having less than 1 meter resolution. So over last few decades, 4 or 5 decades, India has also acquired very good capability in terms of imaging. Now the demand is, they want in time scale, every half an hour they want image, every 1 hour they image. That's the kind of challenging is there. First challenge was to get the high resolution pictures, which we have achieved it. Now they are asking to make what you call as a clusters of satellites or a group of satellites, which can give any particular Udaipur city every half an hour if they want image. As in today, it is not possible, but there is a company called Planet Lab which gives you. However, India also is working towards that direction. We should have such a hourly based what we call satellite constellation. Maybe in soon we will be seeing such kind of a development in India. However, to record here, we got a good progress or evolution of resolution in terms of up to less than a meter or 0.3 meter, 0.27 meter, like that. So that's to make a record that our the detector, or what we call it as a capability in terms of cameras, to provide high resolution pictures which can be used for many applications. Next slide, please. Similarly, for space science, as we are aware that Astrosat, Chandrayaan-2, Chandrayaan-3, see, it started Aryabhata as a science mission. From Aryabhata to till date, we got huge number of satellites. Recent missions are Chandrayaan-3, Exposat, Aditya. See, when I say these things, you may sound very little, but it's a tremendous amount of work has been done by more than 20,000 space engineers to make Chandrayaan-3 successful, to make Aditya L1 successfully being operated. A lot of scientific papers are being published. In Astrosat itself, 450 papers, more than that papers are published. Around 50 plus PhDs have been done. So you have to also help our academic intellectual people by making certain satellites and observations. That is the kind of contribution to the space science experiments by ISRO also. In future, we will be seeing more and more such mega science projects. Next slide, please. Yeah, that's how ISRO has many satellites which are there around both in terms of low Earth orbit as well as geostationary, which is providing lot of applications, environment, forest, border monitoring, whatever field you take, even your ATM is operated by satellites. Lot of benefits are there from remote sensing satellites, like city planning, water resource management, fire, landslide. So many applications are there. If you happen to visit NRSC, National Remote Sensing Center in Hyderabad, you will see lot of application areas where thousands of people are working for countries overall national natural resource management. So a lot of applications are there: groundwater monitoring and mapping, water, wastewater, wasteland. All those applications are possible. Satellite can do whatever you think, you imagine that can be possible using the satellite data. Maybe at this point of time, I request students to look at Google map of one particular airport, probably Ahmedabad or Delhi airport, and same location you can look at Bhuvan, which is indigenous, our own thing. You will get different time scales thing. So you will see in Google Map, latest advanced will be there. In Bhuvan, you will see all for last 5, 10, for 20 years, all images are available. People can make a small exercise. Next slide, please. So using satellites, how you can study. When we started, I told you Tumba Equatorial Launching Center, around 15 kilometer, 20 kilometer, maximum 100 kilometer. That's how we started our what you call moving towards sky. When you are moving towards sky, you should also get information from my moving machine, either rocket or aeroplane or anything you assume, that we call it as a telemetry. That means I can do certain measurements from a distance. It's called telemetry. So India is now capable or having a capability. It started from 10-12 kilometer distance of telemetry. Today it is more than 225 million kilometers beyond Mars. Even we have a capability to go beyond Pluto, beyond our solar system. You don't have to depend on foreign countries on this. Suppose a student comes up saying that, sir, I have a satellite, can you launch it beyond our solar system? India has all necessary infrastructure to keep control of it. When we say telemetry, you should keep control of it using telemetry, telecommand, and network. So we have that capability. That's what this slide shows. You started very modestly from 10-15 kilometer. You have crossed beyond 225 million kilometer. And beyond our solar system also, we have a bigger antennas in Bengaluru, which is 32 meter, 18 meter, even whatever 1.5 million kilometer Aditya is there. Daily 12 hours we have been tracking, collecting the data, receiving the payloading it. That is the strength of India in terms of reaching beyond. Next slide, please. These are the ground stations to support that particular ambition. That all over the globe we have got our own stations. Antarctica we have our own stations. Svalbard we have our own stations. Tromso we have our own station. Maybe in the next few slides I will be showing few antennas so that they get an idea how antennas are playing important role. See, when a satellite goes around Earth, wherever it is there, if you raise your head, satellite is visible. Assume like that. For an antenna, I should be able to track throughout. See, one orbit is around 90 minutes time. At least I want to track full 90 minutes. Then I can collect the data. So now huge plans are there to have our own ground station. Even in this domain, a lot of private companies have started to establish their antennas and support our Indian program. It is not ISRO alone, Indian program. Next slide, please. This is the place where I work, which is nearby Bangalore. It is having 32-meter antenna. We call it as IDSN, Indian Deep Space Network. You can see BL4 means for the 11-meter antenna, BL5 means another 11-meter antenna, and new 18, N18 we say, which is also used for Aditya. See, Mars, Chandrayaan missions, Aditya, all AstroSat and XpoSat, all those satellites are being controlled, received data, and it is hosted. Those who are interested, you can log into issdc.gov.in, https://iswww. You just put in Google ISSDC, Indian Space Science Data Center, where students can download data and do lot of projects in terms of BE, BSc, MSc. Even many students are doing PhD by downloading Aditya data. and they are collaborating with PRL, they are collaborating with ISRO, many other things. That's how our ground station play an important role. See, one person will make rocket, another person will make, and center will make a satellite. Who will control? We are controlling. Simply controlling is not sufficient. You have to collect the objective. What is the data? Scientific data, you have to collect it and give the data to the user, scientific user. That's how it is happening. Similar facility is there in Hyderabad for Earth observation, remote sensing satellite data. Next slide, please. Here, I think in Bailalu, maybe here I will be showing just antennas. You can slowly, every 30 seconds, we can change it. I have a request here. Those who are interested from all over India, people are visiting to this Bailalu. Just you can send it to our Ristrack. You can log into our Ristrack page. Their mail ID is there. You can give a request. They will allocate a time. People can visit. This is a 32-meter, 18-meter antenna. Here, one important point I would like to mention is it is not only a land-based antennas. We have also antennas which can be positioned on ship and can be deployed ship on any particular place on ocean. Wherever satellite goes, normally what happens, mission planning is depending upon the scientific objective, the trajectory will be designed. So satellite will go on a no land place, on ocean. Then who will track when you go on ocean? So we will deploy antenna for Mars orbiter mission, for Aditya, even for Chandrayaan 3, we have deployed antennas on the sea surface using shipboard terminal. Next slide, please. That's how we support. This is all how a ground station looks. Next slide, please. This is a trajectory which I was telling. No, why do you need a shipboard? And look at that eastward. For example, GSLV for yellow color one is a southward. Recently, our GSLV went southward only. Those who have seen recent NISR mission. So whenever you are an eastward, you have a lot of land masses. We will have an agreement with them, and we will put our antennas there. We can easily track it. Whenever you go for a southward, you see after Sri Lanka till down, we have to track, right? So recent NISR mission happens almost similar to this one. So on Antarctica you have antenna. In between we can place a ship. We didn't do for this NISR, but in other missions we have kept it depending upon the need, visibility, all those. The yellow circles and pink circles tells you if you stand at one particular, let's say you are standing in your place, just look at above, you will see first 90-degree circle. Then if you are good enough in both alt azimuth angles, you can see 180 degrees. This is a visibility circles we say. If rocket or satellite is moving within the circle, that particular ground station can collect the data, telemetry, telecom and all those. Next slide, please. This is how satellite trajectories are being tracked. Lot of spacecrafts being controlled in our Bengaluru place. Once the satellite is made, it will go to Sriharikota. Rocket also will come to Sriharikota. Sriharikota, it gets integrated or assembled. It is launched. The job is only 15 minutes. After 15 minutes, it is visible to Bangalore. It is visible to Lucknow. In 90 minutes around the world, it is visible all over the world. Wherever we have a ground station, entire data has to come to be Bangalore, Pune, where the brain center are all topmost scientists who designed, developed, are involved in that particular project will be sitting there for the first 3 months of period. They will make all analysis, initial analysis, make the satellite healthy. Right now, you might have seen last week, NISR has opened its what you call unfurlable 12-meter antenna. So that all activities are happening from Bangalore. So like that, this is a brain center. Afterwards, once it is normalized, it will be called as a normal phase of operation. Satellite will be on in the orbit. Whenever there is a need, people will come and attend. Otherwise, it will be deployed for the user's request. Whatever user wants, he can collect the data. So NRSC and ISSDC, these two are the nodal agencies. Bhunidhi is there. You can go to Bhunidhi, Bhuvan, then NRSC website or NRSC data center, ISRO data center, where you can collect the satellite data depending upon your choice. You want a science mission, you want Earth observation mission. If you want a weather, MOSDAC, MOSDSC, MOSDAC. Next slide, please. Hope I am in time. Time is more. I will quickly finish it up. This we can skip it. I have told already there are 26 satellites there. This is another interesting experiment which ISRO has done. I think Manish was also involved in this mission during his early career. NavIC, navigation using Indian constellations. We are going to increase this particular in future. We need to have a more satellites to give services exactly similar to GPS. Right now it is being used in aviation, railways, roadways, but we want to see this particular service is available to every mobile. Right now mobiles are manufacturing chips compatible to NavIC signals. However, we have to go for a larger what you call user services in this particular. It's an interesting experiment which we call it as a NavIC and Gagan, which is successfully demonstrated. However, we have to go for a user services. Next slide, please. This is a place where navigation satellites are being controlled. Next slide. This is the entire, this we can skip it, computer and hardware network available for that. Yeah, this is already explained now, skip it, no problem. This is another interesting thing is those who are interested in communication. Small antennas will be used to communicate to satellites. Maybe Starlink. If anybody is familiar or read in YouTube or seen the YouTube channel, you will see small antennas are sufficient to track satellites. We too have such small antennas to track. Depending upon the location where we don't have antenna, we get the data back to Bangalore. It's a very interesting experiment. Domed antennas, open antennas, small MVSat antennas. All those things are very useful in tracking all those satellites during the launch as well as during the orbit. Next slide, please. Hope I may not be skipping. This is the Indian Space Science Data Center, which I already told. Please visit to issdc.gov.in, where you get lot of Chandrayaan 1, 2, 3, Astrosat, Mars Orbiter mission, Aditya data, ExpoSat. All science missions of ISRO data is available. No need to pay anything. People can download, do certain small projects, submit to your teacher, submit to your college, even to the PhD level. Small internship to PhD level data is ready. If you ask me 10-15 years back when I was student, our teacher used to tell go to NASA website and download moon data, download sun data. Today it is not so. If you want sun data, please download from NASA data. We don't discourage you, but you have your own repository by India. Aditya L1 data is available. We can maybe compare it, understand it, learn something new, join ISRO or join similar agencies. You develop this particular field into a bigger area where you have a platform in India. You don't have to go anywhere else to do astronomy, astrophysics. India is also good, both in terms of ground observatories, both in terms of satellite observatory. We have 7-8 satellite data available. Lot of papers are getting published. Last week, one paper was published on using the Chandrayaan 3 data. It's an interesting thing which is happening within India that we call as Atmanirbharata in terms of space sciences. Next slide, please. Now, this is I picked up this from ISRO website because our vision and mission is redefined over the years. When Sarabhai was there, was one way of looking at the satellites. Now we have to harness, sustain, and augment the space technology for national development while pursuing space science research and planetary exploration. Those days, it was only to use satellites for social applications. Now we have gone beyond. Next slide, please. We are now going into bigger advanced remote sensing satellites, high throughput communication satellites, 72 Gbps. That's what people are talking about. And navigation in terms of MEO orbits, Gaganyaan series, which you are already seeing. Shukla's episode is one small step towards that, sending humans to the space. Chandrayaan, you have already heard, Chandrayaan 3 successfully landed. Chandrayaan 2 is still working and giving you very good quality data. In future, we also want to have a Bharatiya Antriksh Space Station, we call it as a BAS. There are certain missions to Venus and huge big launching vehicles, we call next generation launch vehicles. And ultimately by 2047, Government of India is directing towards having a moon base where Indian can land and come back. That is the kind of very ambitious program which is led before the country. By the time you qualify as engineers, and you can also work with ISRO or ISRO-like institutions where you can contribute to the country. Next slide, please. From here onwards, I may go a little bit quickly because time is also important. Now, these are the upcoming missions which I have told you. EXO World mission which is coming up. Next, astronomy missions are coming. Disha is there. Then Mars lander, people are talking. Venus orbiter, some progress is happening. These are all the missions, satellite missions, where in future you people will also take part. When I was a student, I was listening Astrosat in our college. When I qualified from college, I got an opportunity to work for more than 5 years in Astrosat mission. That's the kind of opportunity India is giving. Hopefully, it may not be huge number because ISRO employs around 20,000 or less than that. Maybe those who retire, you will get an opportunity. That's the kind of opportunities are available. However, as a researcher, huge opportunities are available. Next slide, please. This I will skip it because I have explained the satellite rockets thing. Coming to the Gaganyaan, because our theme is Aryabhata to Gaganyaan. So last 5 6 years, ISRO India, it is a national program. All of us are working towards making Gaganyaan a reality. Few successful steps we have seen. Test vehicle successfully launched. A crew module is successfully made. A launch vehicle is successfully available. Four astronauts were selected and they were trained. One of them got an opportunity to go to International Space Station and understand the dynamics there and the different facilities, and the experience of microgravity is very rare. So that has happened. Maybe in couple of years we had a pad abort test. Couple of years, maybe in a couple of months, we will be seeing first Gaganyaan 1 mission. In 1 or 2 years, we should be able to complete the first manned mission. That's the kind of busy schedule which is going within ISRO. People are all are working on making this dream into a reality, and slowly, next let me slowly towards the Bharatiya Antariksh Space Station. This is one small slide. I don't think it, but quickly I'll finish it. Whenever you are in space, there are certain threats or debris we call them. Somebody has to monitor it, right? There's a new area. ISRO is getting expertise in this domain, whether it is an asteroid, whether it is the spent rocket body or fourth stage, which is we call it as a what we call passive objects. It could be of order of 10 centimeter to few meter satellite parts which are inactive. Those are all there. More than 27 to 30,000 objects are there, both active and passive. Somebody has to monitor, right? Why we have to monitor? Because my active satellite is there. It should not come and hit. When I am launching a rocket, you may be seeing Chandrayaan 3 when it was launched. It was delayed by 3 seconds. There are other missions you can see in news. Rocket launch is postponed, preponed by few seconds only. Lift off time only they will change. That is mainly because they will be observing certain this kind of a bad boys, or we call it as a debris, or in general technically we call it as space situational awareness around Earth, around the orbit which I am going. That should be very good for me because no other object should come. Like a traffic jam, no? If traffic is clear, you can easily drive that way only. I'm saying, but not imagine traffic kind of a congestion. However, congestion is there because Starlink more than 6,000 satellites are there. OneWeb more than 800 satellites are like that. So many satellites are going. ISRO has 55 plus satellites. China has 2,000 satellites. America has 3,000. Like more than 30,000 objects are nearly 30,000 objects are there. When you have such a huge number of objects, when you want to place a new satellite, you need to have an idea of space situation where what object is there which is going to come and collide. Next slide, please. You can discuss this subject itself more than an hour. This is how the process, how they calculate. They say that space object proximity analysis, launch collision avoidance, then re-entry analysis, then space subject observational data. That means you have to have a lot of telescopes, ground-based optical, ground-based radars. You have to have scan the entire sky, collect the object's information, and you build a database so that anybody can analyze the data and say that my satellite is not going to hit. If in case going to hit, we call it as a proximity analysis. Based on that, if your object is having fuel or my satellite is having fuel, we both talk to each other. American satellite or Indian satellite. Ground, our engineers will talk to each other. Hello boss, my satellite may collide with your satellite, or your satellite may collide. So whatever may be. Can you lift it up? Can you lift it down? This kind of a discussions will happen, and certain activities will be taken care so that satellites on space cannot collide. That's the important thing. That's called a space situational awareness. In ISRO, we have a very good office there. A lot of engineers are working where we are taking care so that no collision. I think you have never heard any collision of satellites in space. Next slide, please. I think maybe I've come close to the end of the thing. So if you have understood the space as a government business all these years, it's all right. Now space is not only a government business. Any private players can enter. These are all ISRO. I told you ISRO means NSIL, New Space India Limited. In space, ISRO, VSSC, so many institutes are there. Keep moving, no issue here. Lot of ISRO and other things are there. However, lot of private companies have come here. This slide you can see here. You can see Bellatrix, you can see Skyroot, you can see Roger, so many. I think to my recent updated information is around 300 startups are there which are working in the field of space. It could be rocket making, it could be satellite making, it could be controlling the satellites, it could be debris. I told you, know, space situational awareness, debris tracking. There is a private company called Diganta in Bangalore. Their job is to track the objects in space and make project out of it. And Skyroot, which makes these rockets. Pixel is a company which makes the satellite. Then you have a SkyMet, is a private company which gives the weather prediction based on the satellite data. You name an area. Now India has vibrant ecosystem of private startups which are working in the field of space. Of course, ISRO is also enabling them, helping them through InSpace, through NSIL, where, see, after all, they are all our Indians. They want to do some technological challenges and they want to achieve something. So we are helping them. There is no threat to ISRO by having such kind of a program. ISRO also is developing in a faster way. We need, India need more than 150 satellites. That's what his chairman ISRO says. So in that direction, ISRO alone cannot make all satellites. So a lot of startups, private companies, all should join together, make a very good space ecosystem. Next slide, please. I think I have exceeded only 10 or 12 minutes. I'm sorry for that. However, what I would like to conclude is, so more than 1,500 years, whatever the Aryabhata has installed in our minds about the space, today India is on par with any other nation. If you have seen last a month back, American satellite was launched from Indian soil. If you look back 3 years or 2 years back, United Kingdom's satellite was launched from India. Those who were ruling us for more than 300 years, they don't have even today their own rocket. They are good at making satellite, whereas India is having a rocket of our own, what we call made in our own soil. Like that, if you compare across the globe, we are having a very good space ecosystem, which we should be proud of it. Please join, contribute to the space sector, whatever capacity you can. In the same legacy will be continued. We will have more number of Chandrayaan series. Gaganyaan is going to come up. So ultimately, I would like to say ISRO story is not simply to inspire. It is to create a knowledge, create an ambition, to create a progress for the country, to stand among the world countries respectfully. So I would like to conclude here and thank our Nimbus Education, especially Mr. Purohit, who is an extraordinary knowledgeable person who is doing a lot of good work. He has given me an opportunity to speak to the students. I hope I might have reached in an appropriate way. Anyway, if it is bored, if it is made less interest, I apologize for that. Hopefully, whatever doubts and questions are there, we can discuss. At this juncture, I may stop over to Manish and his team. Please. Yeah. See, what I have shown is ground-based observatories. We call it as telescopes. For example, if you want Mount Abu Observatory, please visit PRL website where the student reach section is there, or HRD. Generally, if you want to visit any center, HRD page, if you see it, there will be mail, or a director of the center also mail will be there where you can write. You can visit all these observatory which is shown. It is less secure. That means there will not be more security, like unlike ISRO. If you want to visit ISRO facility, like I told you, you can visit URR Satellite Center. You can visit our Bailalu, where we have a 32-meter telescope or antenna. You can write to our HRD, where you can visit. They will also host some student. Right now for National Space Day, lot of students have been invited in terms of open day or in terms of quiz, in terms of debate. Many students are coming. Even for my center in Bailalu, people from Rajasthan, Delhi, people from even Uttarakhand. I think one person in Uttarakhand who is an MP, who has sanctioned 60 students air ticket to Bengaluru, Bengaluru to back to their city. I have interacted with the children. Nowadays, people are interested through some means. If only traveling expenditure is involved. Otherwise, you write to any of the center directors or HRDs, they will very happily. But only thing is time matters. This month or next month, depending upon the allocation slot, no, we will give. Definitely, you are all welcome. Please do visit. Otherwise, you will not understand if you don't visit the places. Good question. Thank you. Yes. See, those observatories which are on ground can receive two types of radiation. One is optical radiation because let's say that we can see through our eyes stars. Similarly, optical telescope can collect. Same way, I showed you antenna of GMRT. Radio waves also we can collect. These two radio astronomy as well as optical astronomy, if you want to do, you can do from ground. I want to collect X-rays, I want to collect gamma rays, I want to collect infrared rays, I want to collect UV rays emitted with, then you cannot do from ground. So you have to obviously go to the space which is beyond our atmosphere because atmosphere is protecting us. Okay, so that's the reason you have a James Webb Space Telescope. See how the James Webb is a infrared telescope, whereas Hubble is optical plus near UV and that way. Whereas AstroSat is a multi-wavelength astronomy. You can do optical, you can do UV, you can do X-rays like that. So if you want to study the celestial objects in different wavelengths, you have to go to space. If you want to do optical on the ground, you can do ground-based telescope. That's a major difference. Thank you. Yeah. See, mainly without software, without computer steam, no space industry can progress. This is a simple terminology which I would like to say. However, recent advancements in AI is helping lot of automation in satellite, what you called operations, satellite data analysis. See, if you want to do a large data analysis, now conventional practice of software engineering may not be sufficient. You have to go for a AI type of methodologies, different machine learning methodologies. So hopefully we will be having what you call, see, right now only AML last 1 or 2 or 3 years only it is booming up. People are having some skeptics about it. It may be good, it may not be good, because the moment you say AI, we see in internet all negatively used AI, right? All heroines को marking करना, this type of, that is not the correct way of usage of AI technology. We need to use AI for large data collected from satellite, then analyze, identify patterns, do society helpful projects using AI. Lot of scope is there. As of now, onboard automation is being done using AI methodologies. Ground data processing is done by that. So many applications are there. I, at this point of to answer this question, I also caution the moment you say AI, there is a negativity associated with AI. All those things, please don't get deviated by that. Do a sincere AI degree, work towards scientific projects, apply your AI technologies, not only in space industry, even share market, huge data is there. Lot of AI applications are there, CCTVs, traffic monitoring, lot of AI methodologies are already being used. People should work in that direction. I have a strong advice. AI means forget that negative picture which is shown in social media and TV, all those things. Please use your AI skills and technologies for the betterment of society. It is possible in space industry also. Thank you. Correct. You are exactly right. Yeah, exactly right. No. Yeah. Exactly, very good question. I think he is also right. One ground station in Tamil Nadu, exact name I forgot, one city name, where a private ground station was established. However, if you look at Amazon, no, Amazon means not this shopping Amazon. Amazon services are there where they will hire ground station all over the world. That is one way of it. Second thing is people are now coming forward to have their own ground station. For example, certain colleges have started as a part of their academic and as well as the student satellite project. However, commercial based also, now all over the world we need antennas, we need the ground stations. It is having a lot of prospectus in terms of business. The money is calculated in terms of minutes of operation, like how many minutes you track. That's the way they charge the services. As of now, all these years, government was only involved in ground station establishments. Now it is also leveraged. I think if you look at the FDI policy on space for ground stations, it is 100% FDI. So anybody can invest money and make satellite tracking ground station, depending upon whether it is for internet application, for earth observation, or TV communication, all those things. It is opened up. People are already thinking in that direction. They are having their own. See, those make satellites. They want to have their own ground station. It is possible. However, ISTRAC is also now a player in the market that we are also going saying that we have an antenna, please use it, and we will also charge them. So earlier we were not doing that way because now the policy is changed. ISTRAC also is providing service and making money apart from serving ISRO satellites alone, which is free of cost to ISRO because they are ISRO part of ISRO. However, we have the record of giving our services. In future, people will have. Only caution here is ground stations are very expensive. However, it has a long duration operational life. That investment can be recovered depending upon the continuous customer what you call usage. Yeah. Thank you, Manish. Thank you for hosting such a good program. Hope all are benefited. Please do write to Manish if you have any doubts. I can discuss with him and share later more details. Thank you. Shall I leave? Thank you. Bye bye.